JMath.
This is the second practice video for compound and double angles. Please pause the video, try these ones, and then see how you did. Let's mark them together. Question 6. So now I just need to simplify. So I'm going to expand and use my formulas as much as I can and see if it simplifies to a single number or a single trig ratio. So at the top, I can see those brackets are squared. So I'm going to do two brackets and I'm going to FOIL it in. So if you need to, please write it out twice and follow all your FOILing steps. Okay, so I know cos times cos is just cos squared. Then I'm going to multiply the cos with the sine, and I'm going to do it again. So there is going to be a minus 2 sine A cos A in that one. Then sine times sine is always positive sine squared A. Okay, great. The bottom, I can then actually expand because that is a double angle. So 2 sine A cos A minus 1. Okay, now at the top, you need to get used to this one. It is in so many different sums, and don't get stuck with this. If I reshuffle this to put the ones with squares next to each other, I am going to get sine squared A plus cos squared A minus 2 sine A cos A. Okay, now at the bottom, it looks almost similar to the top. It has the same 2 sine A cos A. So I'm going to switch the order at the bottom, and I can do that by just taking out a minus. I'm doing a sign change rule. So I'm going to say minus, and that's then 1 minus 2 sine A cos A. Yeah, the reason I did that is because the top sine squared plus cos squared is always just a 1. And then at the top I have 1 minus 2 sine A cos A over minus, and then also 1 minus 2 sine A cos A. And great, those brackets would cancel, and the answer would just be 1 over minus 1, which is just minus 1. So you would get your marks for expanding up top using a double angle, foiling, then for doing a sign change at the bottom, then for seeing the sine squared plus cos squared is just 1, and then for your answer. So this one is 4 marks. Question 7. Okay, so now I can see single angles and double angles. So we need to expand the double angles. Now this is where the part comes in where you really need to think hard about which cos double angle is going to help you the most in this specific sum. So I think all of them will work, but one of them is always going to be quicker than the other two. So my rule is always don't introduce a cos if it's not necessary, or a sine if it's not necessary. So at the top, if I can choose, it's not really going to help me to leave the cos as a cos at the top. But if I change it to something that only has a sine, I can actually work with that. So sine x, and then minus, remember your bracket, 1 minus 2 sine squared x. Okay, now at the bottom, I don't have an option. I must just go with the sine double. So 2 sine x cos x minus cos x. Okay, at the top, I'm going to multiply that minus in, and I'm just going to shuffle a bit to put it in trinomial form. So sadly, trig has trinomials. So this would be 2 sine squared x plus sine x, and then minus 1. At the bottom, I'm going to take out a common factor of cos x. So cos x, and that leaves me with 2 sine x minus 1. Okay, so even though this is a trinomial at the top, because we already went a step further at the bottom, I know one of those brackets at the top must cancel out the bottom bracket. Otherwise, there would be no purpose for the bottom bracket. So if I need to think about what my top brackets would be, this would be 2 sine x, and then this must be a 1, this must be a 1, because 1 times 1 gives me 1. And now, to figure out the signs, I can just say, okay, the top bracket must look like the bottom one, so the minus goes there, and then this would just be sine x. I want to end with a negative 1, so then this must be a plus. Great, and then the bottom just stays the same, and now I can actually cancel those brackets like this, and then the final answer would be sine x plus 1 over cos x. And that is how you would simplify it the furthest possible. I know this is a bit tricky because it's not like an identity where you know where you need to stop and you can see the right-hand side, but you can stop if you have single angles and you are certain there's nothing more you can do. So here you get a mark each for expanding the double angles, then for doing the factorization, so the trinomial up top and the common factor at the bottom, and then for your answer. So 5 marks for this question. Question 8. Okay, so that right-hand side looks horrible, but it's actually not that bad. Now, this is one of those sums where you can actually start with the left or with the right. It fully depends on what you feel like. Most people would start with the left, so that's what I'm going to show you today. So I am going to indicate where I'm starting. So left-hand side equals sine 8 theta, but I'm going to rewrite that as 2 times 4a, just to make it easier for you guys to see what I'm actually doing. Now, because that is a double angle, so I can expand that as 2 sine 4a cos 4a. Now, I am going to keep an eye on the answer. I now have the cos 4a, so I'm not going to change that. I'm just going to bring it down each time and write it, but I'm not going to change it. Then the 8, this 2 that's in front forms part of that 8. So I know that 2 I'm also going to bring down the whole time. But I don't see sine 4a in my answer. So that means I'm going to have to expand sine 4a into its double angle. So the 2 stays there. Sine 4a would actually be multiplied by 2 sine 2a cos 2a. and then the cos 4a was there already, and I'm just going to keep it. Now I have the cos 2a, that's there, and I have a 2 times 2, which is going to get me closer to the 8. In this case now, again, I need to expand this sine double angle again. So that would look like this. So 2 times 2, and then the double angle would then be, again, times 2 sine a cos a, and then the cos 2a, I must just write, and cos 4a. And now I actually have their answer. There's the 8 sine a cos 2a cos 4a. Okay, so that's a big one, but I don't think it's too tricky. Just please remember to say left-hand side is equal to right-hand side. So with this question, you get a mark each time you expand the sine double angle. So that happens 3 times in the sum. So 3 marks and then 1 for your final answer. 4 marks for this question. Question 9. If someone were to ask me what is one of the most horrible sums in trigonometry, I would tell them this one is. So it's long, you need to think out of the box, and many people struggle because they don't exactly know what on earth they are asking. Like sine 3a is sine a, so what must I change? What they mean with the question is you can't leave it as a triple angle. Firstly, there is nothing like a triple angle, so I must break that up as 2a plus a, and then I must continue until there is only sine a's left in my answer. So it can't be cos, and it can't be sine 2a. That's how I know I'm at the end. Okay, buckle up, let's go. So first thing, this is going to be sine 2a plus a. Now I can just expand, so sine 2a cos a, this stays a plus, cos 2a sine a. Again, I don't want double angle, so the double angle I can expand. So 2 sine a cos a, and there was another cos a originally. Now with the cos double, I need to choose which one. I don't want coses in the answer, so I'm going to choose the one that does not have a cos. So that's 1 minus 2 sine squared a times sine of a. Now I can simplify this one a little bit to be cos squared a, and then with the right-hand one, I need to multiply the sine into the bracket. So that is plus sine a minus 2 sine cubed a. So that's fine. It's not a double angle, so I can have sine cubed. So now this cos is bugging me. I need to change that into something else. So in grade 11, we said cos squared is equal to 1 minus sine squared. So that's where I'm going. So 2 sine a bracket 1 minus sine squared a plus sine a minus 2 sine cubed a. Almost at the end, guys. So now I just need to multiply this in. This is going to be 2 sine a minus 2 sine cubed a plus sine a, and then minus 2 sine cubed a. So the answer to this horrible sum would be 3 sine a minus 4 sine cubed a. Okay, so let's just see if we answered their question. Everything is sine, and there's no double or triple angles. So yes, I answered their question in terms of sine a. Your first mark you get if you expand the compound angle, then a mark each for doing the double angles correct, then for changing the cos squared into 1 minus sine squared, and then 1 for your final answer. So 5 marks for this question. Last question for this practice video. If cos 2 theta equals 17 over 25, find the value of sine theta without the calculator. Many of you would want to draw a triangle. It's fine, you can, but it's really not going to help you. So in this case, I must just use double angle formulas to change cos 2 theta into sine theta. So that's the first step I'm going to do. 1 minus 2 sine squared theta is then equal to 17 over 25. And now I can algebra until sine theta is alone. So first step, I'm going to take over the 1. So minus 2 sine squared theta is then just equal to 17 over 25 minus 1. And that would just give me minus 8 over 25. Then I'm going to divide by negative 2. So sine squared theta is equal to, if I type that in my calculator, divided by negative 2, it would just be 4 over 25. Then sine theta would just be equal to the square root of 4 over 25. And that is then plus or minus 2 over 5. Okay, so many times if they start you with a double and they want a single, this is the route you need to take. Okay, great. That was the revision. Let's now do the marking and see how it went. You will get your marks for choosing the correct cos double, then for taking over the 1, dividing by minus 2, and then for getting the square root, but remembering the plus minus. So 4 marks for this question. So how did you do? How much did you get out of 22? Do you feel you understand this concept, or do you need to go back to a few videos and just sharpen your skills? Good luck with the rest of this chapter.
If this video helped you, please like and subscribe.
JMath.